This is Algebra 2 with Trig. We are doing the review for the quiz on system of equations. We're going to first start with our system here. We're going to graph this. It's a little tricky one, but the first step typically would be to convert this over to y equals mx plus b. And then we would need to get to y by itself. So we look at this y-intercept of 14/3, and we don't want to plot a point that is an approximation. We want to plot them right on the integer locations. So we have to find other points that could possibly work. Here, when we plug in 0 for x, that still gives us this y-intercept, so that's not helpful. When we try 1 for x, we get 5/3. 5/3 minus 14/3 gives us negative 9/3, which is actually negative 3. So we have this point at 1 comma negative 3. So what I'm trying to do is find a point that exists on this equation. You can either do it from your original equation in standard form, or you can do it in the y equals mx plus b format. You pick a value for x and you solve for what the y would equal. Let's see, we make our xy axis. I know I have this point at 1 comma negative 3, and I have a slope of 5/3. And we would connect those. Use a straight edge. And we can label our equation y equals 5/3 x minus 14/3, or you can use a standard form of 5x minus 3y equals 14. Okay, we'll start with the next one. Our next one here, we would, it's a little bit easier, minus the 3/4 x and the positive 2, so we're moving our x across. Then we're going to multiply by the denominator, a negative 2 all the way through. By multiplying by a negative 2, we're going to get 6/4, which is 3/2. And by multiplying by a negative 2, we get negative 4. So at 1, 2, 3, 4, that was almost right on it. We have a slope of 3 up over 2. Just missed it. Up 3 over 2. Right on it. There's the intersection. Up 3 over 2. Just missed it. Still missing it. It's only going to cross in one location. So down 3, backwards 2. So we have this point. The lines are really close to each other. Okay. There they go, and this is the equation y equals 3/2 x minus 4. And if you'd like to turn that one into a different color, highlighter works pretty good, doesn't bleed through too much. Okay. So there's your system of equations, the point that is a solution for both of these equations. So similar idea. We're going to take our negative 4y, subtract the 8 across, divide by the negative 4. That comes out really nice. So we're up at 6 and a slope of 2. So 2 over 1, 2 over 1. They're both negative numbers because that's a positive slope. Use your straight edge. And that's y equals 2x plus 6. And then our other equation here, move the 5x to the side. Negative 15 divided by the 3 leaves us at a negative 5. And we have a slope of negative 5/3. So we do 5. So that's a positive 5 and a negative 3. Oh, puts us right there. There's our solution. Get your straight edge. And label your equation. You want to make one of those a different color to make it look nice. Okay, we're going to look at our next system of equations. This one is a system of inequalities. Well, we're going to work it out the same way. We're going to take our 4y, subtract over our 3x, still has the minus 1. We're going to divide by the 4, and that gives us a y-intercept that's kind of difficult to work with. If we try zeros, try 0 for x, that didn't get rid of it very well. We're going to try 1 for x. 1 is going to give me that number. So negative 3/4 minus 1/4 gives me negative 4/4. So that gives me a value of negative 1. So now I have this point at 1 comma negative 1 that should have negative 3/4 as our slope. So we have the point 1, negative 1. And we have our negative 3 slope. So negative 3/4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. Positive 3, negative 4. Now we have to look at the inequality to see if this is going to be dashed. No, yeah, this is dashed. It is not solid. Because we are y is less than. So, since it's y is less than, we go to any of the points and we go less than that. We should label our equation. Then we take the next equation we have here. Negative 3y is greater than or equal to 2x plus 22. That gives me y is less than or equal to, because I'm going to divide by a negative, I have to switch my sign. So again, I have this 22 and a third. So that's a decimal version. It doesn't go in there evenly, so we don't want to plot it. Even though we might feel like we can get close, we want to pick a point that is going to be good. If you look here, 2 and 22 make 24. So it looks again like if I try x equals 1, then I'm going to get a value that's going to work pretty good here. When x is 1, I'm getting negative 24 divided by 3 is negative 8. Let me check my work again there. And see, when I brought the 2x over, that should have been a negative 2x, which would have divided by 3 would have given me a positive 2/3, and 1's not going to help out in that case. Alright, so another option that we have is that when y is 0, x, here we come back here and it helps out a lot. When y is 0, we can solve for x, and x is going to be 11 divided by 2. So when y is 0, x is 11. So when x is 11, the y value is 0. And if you notice that here, 11 times 2 is 22, then those will cross out and be 0. But it's easier to see from your original. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's one little dot out. I can be pretty accurate with that. So we'll do negative 2, negative 3. Negative 2, right there's our intercept. Negative 2, negative 3. This was our old point that we made a mistake about. Negative 2, negative 3. Two negatives make that positive slope. Connect those together. This is going to be a solid line. It's a solid line because it's, in this case, it is less than or equal to. So we can label our graph as y is less than or equal to 2/3 x minus 22/3. And the shading in this case is also down. So it looks like our double shaded region falls in here. You want to make that a little bit darker so it's very clear where our solution is. Good job. Come on over. We'll take our 3y and subtract over the 5x plus 12. In this case, 3 goes into 12 nicely. Next equation, divide by the negative, so we're going to switch the sign. The negative would go into the denominator, so it's 2 times 4, which is 8. and divide to get positive 4. Looks like they're both positive 4, so that's actually our point that they're the same. We have one equation, positive 4 with the slope of down 5, positive 3, up 5, negative 3. And look at your inequality again. Be sure if it's going to be a solid line or a dashed line. Our equation is going to be y is less than or equal to negative 5/3 x plus 4. And then we have a slope of negative 3. Let's check out our slopes again here. We would have subtracted this over. It should have been negative divided. This should still be a positive. Sorry about that. Right? When we would subtract the 3/4 to the other side, there would now be a negative 3/4. And then to divide, be two negatives, make a positive. Anyway, we're still with the same y-intercept. And you'll have to look at your inequality to see what's happening. And you'll see that there's no line underneath the inequality, meaning that this has got to be dashed. Your boundary line. So the first graph is going to be less than. So you go to all your intercepts, all your points, especially your y-intercept, and go down from it. And then here, y is less than is also down from it. So this shaded region, make it a little bit darker. So it's very clear where it's at. There you go. Here we're going to write an equation that has a solution of negative 4, negative 3, and that neither equation can have a positive slope. So we're going to have to do a little guessing and checking or investigations with this one, but what's going to make it have a positive slope is if x originally was negative on the right hand side. So we'll have like a 4x plus 5y. We've got to calculate what that would be. So we plug in our negative 4 to get negative 16. Plug in our negative 3 to get negative 15. And those put together gives us a negative 31. There's our equation. Then if you want to look at what the slope would be, your slope is negative. Neither equation can have a positive slope. So this equation has a negative slope. It's because it starts out and would be moved over to be negative, but it's not going to be divided by a negative. If you want to get crazy this time, we can use a negative x, but we also have to use a negative y. So this is going to give us 12 plus 6 is 18. if you wanted to test that out. You see that we get a negative slope. So our two equations are 4x plus 5y equals negative 31, and negative 3x minus 2y equals 18. So those should give us the solution point of negative 4/3. Write a system of equations that has a solution in the third quadrant. So our third quadrant's down here, so negative x's, negative y's. So we can pick a point like negative 2, negative 6. That would be down here somewhere. So we'll do the same thing. Neither slope can be an integer. So this time we need to be sure we get fractions. Well, that's a little bit easy, not too bad, because you just got to make a coefficient to your x, which will typically work out. So we'll try 5x plus 4y, so that gives us negative 10, gives us negative 24, which is negative 34. And by subtracting the 5 and dividing by the 4, we get a fraction. And also negative 6x minus, let's see, in any number. We just don't want it to go into that 6 evenly. So 1 goes in there evenly, 2 does, 3 does, 4 does not. So 4 would be a good number to use. So when we do our calculations, we'll get 12 and 24, which is 36. So there's our system of equations. 5x plus 4y equals negative 34, negative 6x minus 4y equals 36. Write a systems of inequalities that have no solutions and do not contain the origin. So something that might look like this and shade that way. Something that might look like that. No solutions. I was making them overlap. So think about what that means. So let's have it shade and does not contain the origin. Well, no solution doesn't contain anything together, so I guess the origin's kind of ruled out. It's however you want to think about this one now. So what does that mean exactly? Does not contain the origin. So let's say the origin doesn't count for either equation, so we do want it to shade this way. And this one has to be parallel to that and shade this way. And neither equation contains the origin. Okay? So we could use y equals 3/4 x plus 2 and y equals 3/4 x minus 3. And that would definitely represent the graphs that we have here. You could bring over your 3/4 x if you like to. And sometimes people even like to multiply through, to put them in standard form, like to multiply through by the 4. You're welcome to do that. See, now we don't have any fractions. It looks all fancy looking. Multiply by a 4. Alright, that doesn't look so bad. Our next equation here, our next problem that we're working with, is to use your calculator. We'll go to Stat. We'll put in our x values. Put in our y values. So we now have all of our points. You got to notice that the number of terms in list 1 has to match the number of terms in list 2. Go to Stat, go over to Calc, go down to number 4, which is our linear regression. We know what our slope is, and we know what our y-intercept is. So it says use a graphing calculator to find the best fit line. That's going to be y equals 0.375x plus 4. Find the value of x when y is 5.725. So we're trying to find the value of x. So we would take our 5.725 and subtract the 4 from it. So that's how we got 1.725. And divide by the 0.375 to give us 4.6. And let's see, at 4.6 we would get 5.7. That would be in between here. Looks pretty good. And then find the value of y when x is 4. So 0.375 times 4 plus the y-intercept. So we now have this point of 4, 5.5. Solve the system by substitution. That means we need to get a variable by itself. Looks like down here might be our easiest way to do that. So divide by 2, and we have negative x plus 6. We're going to plug that in for a y. Distribute. So 5x, add that across is 25, so x equals 5. So when x equals 5, we can plug that back in. So y equals negative 5 plus 6, so y equals 1. 5 comma 1 is our solution. So for substitution, we get one of our variables by itself. Sometimes you got to be a little tricky on how you're going to do that. So here, not going to come out really clean, but we'll make it work. So we're going to take this equation, divide by the 2, we get 7.5. So we're going to take that up and plug it up here. So 4 times 3y plus 7.5 minus 2y, 12y plus 28 and half of 4. So that's 30. That got rid of it. So we have 10y. Subtract this across to get negative 5, and y equals negative 5/10, which is really negative a half. And when y is negative a half, so that gives us 1.5 plus 7.5, which gives us 9. 9 comma negative 1/2. Here we're going to try to use elimination. So I'm going to multiply through by negative 4. We have 8x plus 3y equals 15, and negative 8x plus 2y equals 0. Add straight down the columns. Y is going to be 3. So I'm going to plug 3 back into either original equation. Since I don't want to take half of the 3, I'm going to plug it into the top one. Got to make plans sometimes. Get an answer of 3/4. So 3/4 comma 3. The last one in this group. Now this one, notice that multiplying by one term isn't going to get us into either equation. Get variable crossed out. So I'm going to have to multiply the top and the bottom. So let's multiply this row by 5 and this row by 2. So that's going to make 6x minus 10y equals 58. Now watch what happens here. Negative 20, that doesn't help a ton, but this gives us positive 10y. The y's are going to cross out. Negative 30. Negative 14x and 28, and look at that. X is negative 2. So when x is negative 2, I can plug it back into either original equation. This one looks a little bit easier to work with. Subtract that across and divide. So we get negative 2, negative 7. Alright. Last question. Always remember, you can pause the video, you can rewind it, check them out again. Here we have a senior class at a high school and a senior class at another high school, and they're going to New York City. The senior class at the first high school has rented and filled 1 van and 6 buses with 372 students. Here we have 4 vans and 12 buses. How much each van and bus carry the same amount? How many students are in each van? X number of students in a van. Y would be the number of students in a bus. So now we write our equation. Senior class at A high school has 1 van. So we have 1 van, and that's the number of students it can carry, plus it has 6 buses, and Y is the number of students it can carry, with a total number of students is 372. The other high school has 4 vans and 12 buses, 780 students. So I'm going to go through here and multiply this row by a -2. We'll get our Y's to cross out. So we take our 372 and times that by 2 to get a -744. Crosses that out. 2x. That's going to be 36. So x equals 18. Looks like each bus carries 18 students per, that's actually a van. Then we can plug that back into either original equation. So we have 18 plus 6y equals 372. That's going to be 354. And that goes into there 5 times, with 5 left over, goes into there 9 times. So don't give that answer as an ordered pair. That doesn't make sense for the problem. It is, you need to have the units. So 18 students per van and 59 students per bus. You could always test that out as 18 plus 6 times 59 gave us that. 4 times 18 plus 12 times 59. Check. Worked out also. Okay, good look everybody.